All right, problem number one on this one. A person rows a boat, blah, 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 blah. We got a resultant velocity. That should be a key that we're using our trig functions. So let's draw it out. So I got 8 meters per second west. So I'm going to draw an arrow to the west. I'll label it with an 8. The stream is going 4 south. Draw it down. And the question is, what's the resultant velocity of the boat? So the resultant velocity is going to be whatever is equal to this side of the triangle. So we got speed, we got degrees, and we're trying to figure out the magnitude and direction that we have on here. So we're missing our third side. That's going to be our Pythagorean theorem. Again, remember, to get C, we need to take the square root of a squared plus b squared. And so in our Desmos calculator, we need to put in a 4 and an 8. I'll clear this out so I can go to the calculator. Excuse me. Not the right one. All right, so square root of 4 squared plus 8 squared, and we get about 8.9. This is our answer for that. So let's go back to problem, wrong assignment. All right, so it gives us our answer. So if we draw it back out, again, I should get around 8.4. I think that's what that was. Let me double check that real fast. 8.94. All right, so that's, I thought that did all right. So we got 8.94 or 8.9. And then the second part of this is what kind of angle do we have? So again, a lot of us have struggled about the angle issue. The angle we're looking at is this angle because we want the angle to be included in the triangle. The first side that we drew is the adjacent side. The second side that we drew is the opposite side. So to get this angle, we can go ahead and use the inverse tangent function. So we're going to put the 4 on the top of the fraction, and we're going to put the 8 on the bottom of the fraction. And because we're looking for the angle, we need to use the inverse tangent function. So we're going to go over back to the calculator and do the inverse tangent of 4 over 8. So we'll get this out of the way. Get our functions, inverse tangent, 4 over 8. And it gives us a 26.6 degree angle. So we come back over here. That tells me that the angle is 26-ish around. And what of what? So again, how did we get here? Think about how we got here. We went south from the west. If you kind of work yourself backwards, this kind of gives you the way to get here. So again, to get from here to here, we have this angle, and this angle is, it has us end up at that position. So think of it working backwards. To get here, I had to go south from the west, and that's how we're going to get that from there. All right, the second question is a projectile question. So we've got an arrow being fired with a horizontal velocity east from the top of a cliff that's 60 meters high, hits the ground, blah, 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 blah. How long did it remain in the air, and what was the horizontal velocity? This is one where we need to break things apart into the X and into the Y and figure out what we've got and what we don't have. So the cliff is 60 meters high. That means, remember, the X is side to side, Y is up and down. So the height of the cliff is going to be 60, and it's going to fall 60 meters. And it's going to hit the ground 930 meters from the cliff. That's going to be our side to side distance. So we're trying to answer a couple of questions. We're trying to figure out how long did it take and what was the velocity. Again, over here, we got some numbers. We know the initial velocity is 0. The acceleration that's kind of covered up is negative 9.8. And we're trying to solve for time. So this is the only box we're missing. We can use this formula to be able to figure this one out. And so we can plug our numbers in. D is negative 60. Since VI is 0, we don't have to worry about that. And it's going to equal 1/2 of 9.8. And we're going to multiply that by t squared. So again, when we do these, I need to multiply by 2. I need to divide by 9.8. And then I need to take the square root. So again, I get rid of that. I'm multiplying by 2. All right, that's going to cancel it out. I'm going to get rid of this. by dividing by 9.8, which is going to cancel that out. And then to turn this into t, I need to take the square root of all of this. Again, that should be negative 9.8 for our distances. So let's see if I can remember that 62 and 9.8. So I'm going to take the square root of, put this in parentheses, 60 divided by 2. Excuse me, 60 times 2. 60 times 2 divided by 9.8. Notice I just, for the sake of the math, I made that both the 60 and the 9.8 positive. If you kept the negative, we would have the same answer. I'll go ahead and make them negative, be consistent. And I get an answer of about 3.5. So let's go back here. So that answers my question number 1. It gives me a 3.5. And then the horizontal velocity, now I can use the other formula because I've got everything except this one. So d equals v times t. In this one, I'm missing v. So let's divide t out of both sides. So distance divided by time equals velocity. So I'm going to have 930 divided by 3.5. 930 divided by 3.5, and it gets 265.7, and that ends up being our answer. Wrong screen again. So that answer would go in here for your velocity. As I switch back and forth, I forget what my answers were. So it was 265.7, and we're done. Right. So again, with these kind of problems, list out your x, list out your y, and use these two formulas to be able to get your answers there. And that's about it.